Right. This wasn't just gradients dying out.
No, the degradation problem was different. They found that if you took a 20-layer plane network and just added 36 more layers to it, the 56-layer network had a significantly higher training error.
And that is mathematically maddening.
It makes no sense.
Because logically, the deeper model strictly contains the solution space of the shallower model. At the absolute worst, the network should just learn to use the first 20 layers to do the work, and then set the weights of the remaining 36 layers so they just pass the data along completely unaltered.
Exactly, they should easily learn an identity mapping.
But gradient descent just could not find that solution. The optimizer was getting totally lost in the depth.
Right, because forcing a standard convolutional layer to learn a perfect identity mapping, to output exactly what was inputted, is highly non-trivial for the optimizer to actually learn from scratch.
Right.
So ResNet introduced a structural mandate, residual path discipline. They altered the fundamental wiring. Instead of treating every layer as a total rewrite of the incoming data, they introduced a skip connection.
A skip connection, okay.
Yeah. The data flows down a main, unaltered highway, and the convolutional layers sit off to the side. They take the input, calculate a delta or a small mathematical correction, and then add that residual correction back into the main flow.
A useful way to think about this is editing a document. A plane network forces you to rewrite the entire essay from memory at every single stage.
Which is exhausting and prone to error.
Exactly.